This lecture discusses normal probability plots. It is the most commonly used approach to check whether a distribution is normal. Of course, you can draw a histogram and check whether the shape of the distribution is symmetric and bell-shaped. However, it is difficult to judge whether or not a shape is bell-shaped. A normal probability plot is the plot of the observed values of the variable versus the normal scores, where a normal score is the observation expected for a variable having the standard normal distribution. Usually, the observed values are plotted on the horizontal axis and the normal scores are on the vertical axis. The bottom shows some typical normal probability plot. The first one indicates that the distribution is normal. If the points roughly fall on a straight line, the distribution is normal. If the points show clear deviation from a straight line, the distribution is not normal. The guideline should be interpreted loosely for small samples, but usually interpreted strictly for large samples. The second plot shows a long-tailed distribution. For a long-tailed distribution, we mean that the majority of the data are concentrated around its mean, but there are some too large and too small observations that make the distribution have long tails on both sides. The third plot shows a skewed distribution. The points fall on a curve. The last plot shows a typical case with an outlier. The majority of the points fall on a straight line with one point far away. Let's look at this example. The IRS publishes data on federal individual income tax return. A simple random sample of 12 returns from last year revealed the adjusted gross income in thousands of dollars. If we draw the normal probability plot based on this dataset, the points fall on a curve. It looks similar to the third plot in the previous slide. It indicates that the distribution is not normal. The distribution is right skewed. Excel cannot directly produce a normal probability plot. We need to follow the steps below to draw a normal probability plot. First, sort the data in ascending order. In the second column, number the sorted data from 1 to n, where n is the sample size. In the third column, calculate I minus 0.5 over n for each value. In the fourth column, calculate the norm score or the z-score for each cumulative probability. Plot the sorted data versus the normal scores. This plot is exactly the normal probability plot. I will demonstrate how to draw such a table in Excel in a separate video. In this example, we will check a data set with an outlier. The U.S. Department of Agriculture publishes data on U.S. chicken consumption. The annual chicken consumption for 17 randomly selected people is listed. The first normal probability plot is based on raw data. The majority of the data fall on a straight line. Only one point does not follow the pattern. This point has value 0. This person may be a vegetarian who does not eat chicken. If we remove this person and draw the normal probability plot using the remaining data, all points fall roughly on a straight line. It confirms that the remaining data follow a normal distribution.